So you are most welcome for this session. Today, we are going to look at integration of odd and even powers of trigonometric functions. And this is going to be our area of concentration. I understand that many of you have gone through integration. At least you have done some basics for at your level at senior 5. So by now, I expect you to be able to integrate when you have sine, to know that when I have sine, when I integrate sine, what do I get? When I have cos, when I integrate it, what do I get? When I have a sec, what do I get? So these are like the basics that we need to know as we go further in integration. So the basic one is knowing that when you integrate sine x, what do you get? That one is very important. And then also knowing when you integrate cos, what do you get? Those are the main ones. Then the rest can come in at a later time. So the major ones, any math student, you need to know is that what happens when I integrate sine. So whenever you meet a sine of any angle, and you integrate it with respect to that angle, you'll always get a negative cos of x plus a constant. And whenever you get a cos of x and integrate it, you'll always get a positive sine x plus a constant. So these are the major ones that you need to know. And whenever what we are going to be dealing with, we shall be referring back to this table. So in case maybe you have not yet done integration at your school, you have not done maybe integration, then please, these are the two basics that you need to know. So like when we are dealing with what you call even and odd, you know very well that when I talk about even numbers, one of the numbers that should come to your mind is 2, 4, 6, 8. Those numbers that are divisible by 2 and you get a remainder of 0. Then when I talk about odd numbers, you know, 3, 5, those are what you call the odd numbers. So odd numbers you cannot divide it by 2. So such numbers are what we are going to be looking at. But here we are going to be looking at the power. Take an example. You are going to be finding sine cubed x. So you ask yourself, which power does it have? Then you know that when it is a 3, that is an odd power. When you find sine squared x, which power does it have? That this is an even power. You find maybe sine power 7x. You know that 7 is an odd power. So we are going to deal with such functions, and we are going to learn how do we integrate them. But as we dive into this integration of them, there are some important things you need to be knowing from your trigonometry. So when you are dealing with the trigonometry, there are certain things that you covered in class. There are certain things that your teacher talked about, and that is where we are going to start from. Those are the key things that you need to remember. You remember, your teacher might have given you some important expansions. Take an example. I know your teachers were able to give you that when I have cos of A plus cos of plus B, when I expand this, can someone raise up the hand and you remind us? When I have cos of A plus B, Arthur Sharon, what do we get? Yes, Zoom user. Zoom user unmute. Lino. People are not unmute.
Yes,
Unmute.
cos
Okay.
A plus
Yes, good afternoon, Arthur.
plus B.
You get? What do you get?
Cos A
Cos A.
plus cos B, cos A cos B, plus, sorry, minus sin A sin B. It's minus sin A sin B. Minus sin A sin B.
Minus sin A
Sin A sin B.
sin B. Okay, very good. Thank you. Now, this one is going to be very important when we are dealing with our angles. What is going to happen? Take an example. We are going to be meeting. Let me say I have cos x plus x. Now, if my two angles are x and x, you know very well that x plus x will give us a 2x. So when I'm expanding, I'll have cos of x cos of x minus sine of x, sine of x. So cos x times cos x will give us a cos squared x minus a sine squared x. But I want you to remember, you know very well that sine squared x plus cos squared x, this one always will give me a 1. But since here I'm in terms of cos, then allow me to remove this sign, and I write it in terms of cos. So meaning that sine squared x is the same as 1 minus cos squared x. So where there is sine squared x, I'm going to replace it with 1 minus cos squared x. So I can say this is cos squared x minus, I open the brackets, 1 minus cos squared x. So when I open up very well, I'll have cos squared x minus 1. Then this and this are negative. So a negative and a negative will give us a positive cos of squared x. So now cos squared x plus cos squared x will give us a 2 cos squared x minus a 1. So meaning that when I have cos x plus x, that one will give us a 2x. So whenever you meet cos of 2x, then it means that we shall have 2 cos squared x minus 1. Now, this is an important property that we are going to be applying when it comes to this, when it comes to dealing with what you call even powers. You can notice that there is a power 2 here. And whenever there is a power 2, that means those are even powers. So whenever you find an even power, then it means that you can express it in terms of double angles. Members, are we on the same page? Are we on the same page? Kindly let me know through the chat. You can say yes, yes. Are we on the same page about that property? Okay, it seems we are, yeah. Now, this is one of the property. So whenever we are going to take an example, they are going to be giving us, find cos squared x dx. Now, when we are integrating such functions that have uneven powers, then we cannot integrate it when it has a squared. So what we need to bring in is the idea of double angle. So we shall be utilizing this kind of relation. Similarly, you know very well that, so this one I've used for cos A, but you know very well that even when I have sine of A plus B, members put for me in the chat, sine A and sine of B, what do we have? But that one is 1. But I know, you know also when we have cos A minus B. So I'm interested in A minus B. What do we get? Even that one. So those are going to be very important when you are doing your expansion, when you are relating. So they're going to be very important. But the most important one is going to be cos 2x is equal to 2 cos squared x minus 1. Now, if I am to go back, I want to remind you that here I expressed sine. What about when I express sine? So you know very well that, like I've told you, that cos of 2x is the same as 2 cos of squared x minus 1. Now, we know very well from our trigonometry, Alice's favor, that sine squared cos squared x will always equal to 1. Now, this equation, we have written it in form of cos. In case I want to write it in terms of sine, then it means that I'll make my cos the subject. So mean that cos squared x is the same as 1 minus sine squared x. So where there is cos squared x here, I'm going to replace it with 1 minus sine squared x. So this will be 2 into 1 minus sine squared x, then minus 1. When I open up the brackets, I'll have 2 minus 2 sine squared of x, then minus 1. Now, what are you noticing? 2 minus 1, when you correct like terms, we shall have something like that. And here, 2 minus 1, we shall get 1 minus 2 sine squared x, and this is equal to cos of 2x. So in case you are going to be integrating something like this, sine power 3x dx, you are noticing that these ones are odd powers. So we are going to be expressing them in terms of an even power, and then we apply something. So that is why we are going to use the knowledge. You find that here maybe the integral is sine squared x, then you need to bring in the idea of the double angles. Now I want to know through the chart, whether people can tell me, what if this relation we had cos 4x, what shall we have? I want us now to start generalizing. This was cos 2x gave us 1 minus 2 sine squared x. What if it was cos 4x? What will it be equaling to? Put it in the chat. Pardon, sir. May I know where? Yes, people, Nakate, Sarah, Janella. Yes, I want to know where I have left you. Yeah, you can raise up the hand and such that uh, I can know where exactly I need to start from. Nakate, Sarah, Janella, okay, Pasco is okay. Yeah, okay. Yeah. Now, what I'm building, I have picked it from what we had done previously. So that is where I have picked it. I'm seeing some answers coming up. Very good. Now, you are not seeing that when I have this angle was a double angle. So here we had a single angle. So it means that when I have cos 4x, I can generalize it as 2 sine squared 2x. In other words, still you go back to your formula that we had, that when I have cos of a plus b, this one will always give me cos A, cos B minus sine of A, sine of B. Now, for you have to ask yourself, which two angles did they add to get the other side? So you notice that when I have 2x, here the angles we added were x plus x. You ask yourself, when I have 4x, which angles shall we add that I can add here? 2x plus 2x. So meaning that the angle I have here will be 2x. Members, now let me ask, what if I add 8? What if I have cos of 8x? What shall we have this side? Members, we are relating. I'm only now relating sine. I'm now relating sine. What shall we have? What if we had cos? We are still writing it in terms of sine. You must look out for those two angles that you add to give you 8. And those angles should be similar. I don't know that people are getting it. Yes, bless. Very good. Very good. I don't know whether Arthur, we are on the same page. Arthur, let me know. Are we on the same page?
Yes, we are.
Okay. Before, don't mute. Just imagine, Arthur. Imagine we had 16. We had cos of 16x. Tell me what would be your equation in terms of sine.
We'd have 1 minus 2 sine squared 8x.
8x. Okay, good. So members, always for you, look out for those two angles that they add a yes. So they should be double angle. But the common ones, I want to let you know, it is going to be 4x, is going to be very common, maybe even 8x, maybe even 80x. Yeah. So, but you need to now to relate. May I know through the chat whether we are somewhere on the same page? Let me know through the chat. Are we on the same page? Yes. Ginela, we are looking at trigonometry. And now we are on trigonometry 2. We are on trigonometry 2 of senior 6. This is trigonometry 2 that you cover in senior 6 term 1. Okay. Members, we are somewhere. But I know when we do an example, it's going to become a bit much easier. So may I ask you now to first write something? You write something. When we do the example, we shall be at the same page. Let's write something. Okay. So some of you may want to slow down. You may want to write something from here. Joy, I'm going to slow down. The moment we reach examples, the moment we reach example, okay. I do believe that where did the sign go on the third step? Yes, now we say that when you look at the third step, when you look at this third step here, we say that we want to write our course in terms of courses only without a sign. So you know very well that when I have sign from here, that's this is a property. Sine squared x plus cos squared x is equal to 1. So we want to replace sine squared x. So if I want to replace sine squared x, I'm going to make it the subject. I will take the cos squared x the other side. So I will say sine squared x will equal to 1 minus cos squared x. So where there is sine squared x is where we are putting 1 minus cos squared x. So that's what we did. Okay. Okay, members, let me know through the chat whether you have finished, and then we'll start. When you finish, you let me know, and then we'll start. Okay, I'm done. We have finished. Okay, now we are going to go back and start on the example. Now, this is our first number. They want us to integrate. Now, whenever you meet these trigonometric functions, and even they have an odd power, the way you approach it should be a special way. And how do you approach it? This is the way we are going to approach it. One, I want you always at the back of your mind to have the properties, the ones that we have looked at, those identities, sine squared of x. Now, what does it mean? It means that we cannot integrate a squared. So what do? We are going to go and make sine squared the subject of the formula. So I'm going to take the 1 this side. Alternatively, I can take the negative 2x this side, then I bring this one. So allow me to first write like this. I'm going to say cos 2x plus 2 sine squared x is equal to 1. Members, is that fine? I've taken the two sine squared x the other side. So I'm taking negative this one. I'm taking it this side. And since it is a negative, the moment it crosses, it will become a plus. Members, are we together on that step? Yes. Now we continue. Now, since I'm interested in making sine, I'm also going to remove the cos 2x. So I'll say cos of 2x minus cos of 2x plus 2 sine squared of x will equal to 1 minus cos of 2x. Meaning that now 2 sine squared x will equal to 1 minus cos of 2x. What am I interested? I'm interested in sine squared. So I'll divide this side by 2. I will divide this side by 2. So meaning that my sine squared x will equal to 1 minus cos 2x out of 2. Members, let me know through the chat whether that step is fine. That is the crucial step that is going to take us go on. That is Elvis. It is fine. Fine. Very good. Now, no sound. Oh, okay. Trace, maybe it is from your ends. Okay. Now, what are we going to do? We are going to go back into our integration here. Where there is sine squared x, we put the whole of this. So I'm going to come here and I say now this is the integral of 1 minus cos of 2x, all of it out of 2, then this one times the x. I've replaced where there is sine squared x, we have got this. But I want you to let you know that this 2, I can factor it out. So I can say a half integral of 1 minus cos of 2x, then everything dx. Members, are we still together? Let us not leave you behind. Now, when I reach at that step, I'm going to apply my knowledge of integration. Now, I want us to integrate. Now, when I'm integrating, I can still first say, because if it is this typing, you can say I have put a good bracket. You break it that I must integrate 1 dx minus also I must integrate cos of 2x dx. Something like that. Now, when I'm integrating, I know when I integrate 1 dx, members put in the chat, what do we get? 1 dx, what do we get? What is our answer? Put it in the chat and I see. No, Janella, here we are not putting it in a calculator. Don't put it in a calculator. Very good. Members here, those who have not done integration, you notice that this is a 1, but there is an hidden 1, an x power 0 dx, because any number to power 0 is 1. So in integration, the rule is that if I'm integrating x power n dx, I will always get that x, add a power 1 on the power, then divide by original power. So here I'll add a 1 here, then after I divide by the original 1, which is 0 plus 1. So that's why we get x out of 1, which is x. That is just side work. So here I'll have a half integral. So here I'll have x minus. Now I integrate this. Now this one, allow me to take you back here. Uh, uh, u out of 2, because the x here, we have said the x is the u out of 2. So here we shall end up with 1 out of 2 integral of cos of u du. Then you ask yourself, from the table, you remember the table I showed you, that with the moment you integrate cos, you get sine. So I will come back here and I say, this will give me 1 sine of u plus a constant. But what is our u? Our u is, so this will be a half sine of 2x. So meaning when I come here, I remain with 1 out of 2 sine of 2x. Then everything, I'll add a constant of integration. Members, let me know. Is that thing fine? Is that thing okay? No, Elvis is saying no. Maybe you can raise up your hand and tell me. Pardon, not yet. Okay. Yet. Now I'm not saying that we call casting a new cos 2x is what has brought the problem. Now I come back here. So you know very well, like I've already said, that the moment I integrate cos of x dx, here my answer is always a sine x. But remember, for you to get sine x plus a constant, here the angle must be a single angle. So whenever you find that it is not a single angle, then you need to devise a technique for you to be able to integrate. The moment you find that the angle here that is being carried by the cos is not a single angle, is not an angle, just one angle, then you must always first use another technique. So when I have cos 2x dx and I want to integrate, now since here the angle is not a single angle, there are like two angles, what I do, I'll first let change of variables is very important. So I'll say let u equals to 2x. Now I differentiate, because why am I differentiating? I want to eliminate the x, and the only way to eliminate it is by differentiating. So when I have u, when I differentiate u, I get the u. When I differentiate 2x, I'll get 2 dx. But my interest in dx, I'll say the u out of 2 is equal to 2 dx out of 2. So these 2 and the 2 cancels. So meaning that the u out of 2 is equal to dx. Members, first let me know, is that one now fine? Is that fine? First let me know in the chat, that first one of just letting the variables. I'm changing the variables now. We are changing variables. That's what I'm doing. Okay, at least we have some people there. Now what I do, after changing those variables, I'm going to go where there is the x here, here, I put the u out of 2. Where there is cos 2x, I'll put u. So I'll have now an integral of cos. Where there is 2x, we have said we put u. Where there is the x, we shall put the u out of 2. Now, this one, I can write it as 1 out of 2 integral of cos of u du. Now, I want you to relate very well. When you look at what we have here, it is the same thing like what we had here. The only difference is this was x, yet now here we have u. So that means that when we integrate cos, we shall get sine u. So I'm going to come here and I say, now this one will give me 1 out of 2 here sine of u plus a constant. Then what was our u? Our u was 2x. So I'll have 1 out of 2 sine of 2x then plus a constant. Members, have we picked something? Have we picked something? Let me know through the okay. Uh, okay, sorry about that. Charlotte, uh, Charlotte, let me hope you will not end the meeting. Yeah. Okay, I was creating to give another example. Now, another example, I wanted to give an example, but okay. Now, someone is asking, how is 2x? I think was it 2x, something like that? How is 2 dx du coming about? Yeah. Now, what is 2 here? Now, you need to remember how to differentiate. That is the most important thing. Remember, you have u equals to 2x. When I'm differentiating, remember, I think you are used to having this. Y is equal to 2x. So when you differentiate y, here there is a 1. Not so, there is a 1 here. So what do we do? There is a hidden 1. And here there is a power 1. Not so on y. So you drop the power. So you get 1. Then you get y power 0. But what have you differentiated? You have differentiated the y with respect to y. So you write the y. Then this side you have 2x power 1. So I will drop the 1 here. Okay, I think you'll drop the 1 here. After dropping the 1, then you will say you subtract a 1. So this will be 2 times 1, x power 0. But you have differentiated with what? With respect to x. So here I write my dx. So here we wrote y power 0 is 1. So here I have 1 dy. Then this side I'll have x power 0 is 1. So 2 times 1 is 2 dx. So you'll have 1 dy is equal to 2 dx. So this one is nothing. So you have dy is equal to 2 dx. So when I divide by dx, I'll have my dy dx is equal to 2. So that's why now, like I think your teachers keep telling you that when I have y is equal to 2x, you just say dy dx will equal to 2. But it comes like this. So the dy shows that you differentiated with respect to y. The x means that you differentiated that given variable with respect to x. So that is where it comes from. Okay, but I wanted to give another example. So that is another example I want to give, because if you don't know how to differentiate these ones, then it may be a bit hard. Another example, take an example. I have sine of 3x, and this is the x, and this is what you differentiate, okay. This is what you are integrating. What do you do? Always look at this angle here. The angle is 3x. So you say u is equal to 3x. Now, when you differentiate u, you get du. When you differentiate 3x, you get 3dx. But since I'm interested in the x, it means that my dx is equal to du out of 3, because when you divide by 3, divide by 3. So that means when I come here where there is the x, I'll put du out of 3. So I'll have an integral of sine of u du out of 3, which will give me 1 out of 3 integral of sine of u du. Then you go back to your table that when I have an integral of sine x dx, this is the same as negative cos of x plus a constant. So here it means that I'll have 1 out of 3. When here I'll remain with cos of u plus a constant, but this cos is going to be a negative. So which will give me negative a third cos. But what is our u is 3x, then plus constant. I don't know whether that is very okay. Yes, Abdallah. Members, let me know. Yes.
Master, yeah, we are moving on well, but my concern is I'm just requesting so that you can send the table again.
Okay, I'm going to put on you screenshots.
Okay, thank you, sir.
Okay. Are the rest of the members, are we on the same page? The negative, Edvis, the negative can't be absorbed. Eh? The negative stays there. Members, are we okay? Okay, now we are going to go back. Now I want to create for you now something general. I want you to observe. Now you have noticed, I told you the things you need to master are the two integrals. Mastering the integral, when you integrate sine, that you get negative cos, and when you have cos, you get sine. So take an example. In case I have an integral of cos 3x dx, what do I do? You have noticed that always what you do, you look at what you have as your angle, differentiate it. When I differentiate 3x, I'll get 3. I'll get that answer. I say 1 out of that answer. Then I look at what I'm dealing with, that I'm dealing with cos. When you integrate cos, what do you get? You get sine. So that means I'll get sine of 3x plus a constant. When I have 5x, 5x, and this is maybe sine of 5x. What I do, the x, what I do, I'll get this 5x, I differentiate it, I'll get 5. So I will say 1 out of 5. Then when you integrate sine, what do you get? You get negative cos minus here, it's going to be cos of 5x plus a constant. I don't know if members are getting the general rule. Even when I have, let me say, sine of 7x dx, I'm going to look at what I have as my angle. I differentiate it. I'll get 7. So I'll say 1 out of 7. But when I'm dealing with the sine, I'll ask myself, when I integrate sine, what do I have? I get negative cos 7 plus a constant. Members, have you picked that, how you can do it quickly? Is the general rule coming? Is the general rule coming a bit? Now, if it is entering, why don't I give you 3 of them and I check whether people have understood? You put your answer in the chat. One of them is here. I have cos of 10x dx. Another one, I have integral of sine of 9x dx. Put for me your answers in the chat. Look at the angle, the size of the angle, differentiate it, then say 1 out of. I'm waiting for the answer. Someone can raise up the hand and you tell me the answer. 1 out of 10 sine 10x. Yeah, I think now, yeah, at least this is very good. This is very good. So for you just know, cos goes with sine. Sine goes with negative cos. Who's getting a half? And I check out, where did you get a half? Okay, okay, okay. This is very good. Yeah, at least I'm seeing answers coming in through the chat. So we are going to go and first complete now our number. So hope now members can relate how I was able to reach this point here. So what is going to happen? I'm going to continue. So when you integrate cos 2x, you get 1 out of 2 sine 2x plus c. Then when I open brackets, I'll have a half x minus 1 out of 4, 1 out of 4 sine of 2x plus a constant. Kindly let me know through the chat whether now we are together on number 1. Okay, can we write now? Can we write something? Can we write now? The first, Natasha, it seems you have just joined in. Natasha, can you raise your hand and you tell us? I want to know where exactly. Yes, Natasha. Nana, Natasha, yes?
I would like to know the cos 2x. Is it an identity where you said cos 2x equals 1 minus 2 sine squared x?
Yes, that is an identity.
Oh, okay.
But I showed you how it comes about. I showed you how it comes about.
I was offline.
Oh, okay. But you'll review and see how it comes about.
Okay, thank you, sir.
Abdallah?
Master, I'll just helping her that she can also find that identity in the logbook.
Oh, okay. Okay. Okay, I think we are good to continue. Let me know. Are we good to continue? Okay. I'm sure now we are done. We are done and very good to go. We can now try out another number. We can try out another number. Now, what we have a sine of power 4 x dx. So what do we do? Now, once we find such a number and we are integrating with respect to x, we are going to express it in terms of an even power of 2. So we shall have integral of sine squared x, everything squared. Because you know very well that when I have sine squared x times sine of squared x, this is the same as our sine of power 4x. But we know from our identity that when I have cos of 2x, this is the same as 1 minus 2 sine squared x. So what am I interested in? Remember, we are interested in having sine squared x substituted. So we are going to make it the subject of the formula and we shall bring it. So we shall have cos of 2x plus 2 sine squared x is equal to 1. A minute. Okay, now, since we want sine squared x, we shall now come and say 2 sine squared x will equal to 1 minus cos 2x. Now, what do we want? What we are interested in is us having these 2 go away. So we shall divide by 2, divide everything by 2. So meaning that our sine squared x will equal to 1 minus cos 2x divide by 2. But when you look at what we have, we are interested in having power 4. But we know very well that sine squared x, all of it squared. So now what are we going to do? We are going to come and say now, since I am interested in sine squared x, everything squared, it means that I'm going to be squaring the whole of this expression. I'll have 1 minus cos of 2x, everything squared. Members, first let me know. Are we together on that step? Abao is saying yes. Is everyone okay now with this step? Okay, yeah, very good. Now, allow me now to divide my board because now I want this part here to expand it very well. Now, when I'm expanding, in fact, let me even change the color. I have 1 minus cos of 2x. Now, I can divide my squared. I can say this is squared out of the 2 squared because this squared affects the numerator, affects the denominator. In other words, it's like having a out of b, everything squared. So you can say I have a squared out of b squared. Yes, Hope a question?
Yeah, teacher, you left me on the third step. My network was jumpy.
Which step? Which step?
Cos 2x plus 2 sine 2x is equal to 1.
Then
Yeah,
did you
that's
get
it.
now are you saying that I'm taking the cos 2x this side? Is that fine?
Yes. Yes.
So what are you noticing that when it comes this side, we shall remain with 2 sine squared x equals to 1 minus cos 2x. Is that fine?
Yes.
Now, the next thing is we have to remove these 2.
Yeah.
So
By dividing.
by dividing both sides.
Okay.
Then that is how we reach here.
Oh, thank you.
Okay. And now when we reach here, members, I want you to know that now I'm going to have 1 minus cos 2x into 1 minus cos of 2x. Then out of 2 squared is 4. Now here, open where the brackets. Yeah, some of you, the mistake you can do, you can come here because some of you want to do things in a shortcut. You may come and say 1 squared minus cos squared 2x. Please, this is wrong. This one is very, very wrong. Don't do like that. You must expand the right way. You must expand the right way. Open the brackets. Don't not jump steps until when you have perfected. So when I open, this one will affect everything here. So I'll have 1 into 1 minus cos of 2x. Then this negative cos of 2x will also affect the other side. So you'll have 1 minus cos of 2x. Then everything out of 4. Now I open brackets. 1 times 1 is 1 minus cos of 2x minus cos of 2x, then plus negative times the negative is positive, so I get cos squared of 2x. Everything out of 4. So this will equal to, now I collect like terms, I'll have 1 minus cos, I'll have minus 2 cos of 2x plus the cos squared of 2x, everything out of 4. Members, let me know. Are we together up to that step? Is that step still okay? Let's not leave you behind. Patrick. Okay, people are saying sawa. Okay, Sandra, let's continue. Allow me now. Allow me
Yes,
to do.
I-
Yes, Patrick.
yeah, I'm trying to ask. I'm always confused, like when you are expanding this bracket where you have 2x, I thought you are also going to multiply okay, you said cos squared 2x. I thought I'm always confused because I think I
Eh,
could take like 2x could also be multiplied, could be 2x
Oh,
squared.
now that is an angle. So an angle, we don't multiply angles.
Okay.
You just multiply the
Okay,
cos and
thanks.
the cos. Perfect. Now, members, where we have our
Okay, thanks.
sine power 4, we are going to replace it with that. So I'm going to come here and I write again that now this is my sine power 4x dx is the same as having integral. Hey, what did we get? It was that whole thing, but I remember it was out of 4. Then up, we had 1 minus 2 cos, this was cos of 2x, then plus cos squared 2x, plus cos squared 2x. Now, when we reach here, members, this 4, you can remove it, and I write it as 1 out of 4, integral of 1 minus 2 cos of 2x, then plus cos squared 2x. Then everything with respect to the x, with respect to the x. Now, when you reach here, you are going to open your bracket very well. So I can say this is a quarter. Now, integrate 1 by 1. So this is 1 with respect to x minus this one. I can put the 2 out and say this is cos of 2x dx. Then this one is integral of cos squared 2x dx. Members, is that step fine? Is that step fine? Just let us know in the chat that I'm still following. Yeah, Mayanja is saying, yeah, okay, very good. Now, we are integrating. This is going to be 1 out of 4, our big bracket. Members, someone to integrate for us. Peterson, let me hope you are raising the hand to integrate for us. Someone to raise up. I want someone who's going to integrate for us the first 2. Yes, Peterson.
I wanted to know, because we have 1 over a quarter in brackets, don't we put another bracket to close all of it?
Okay, here. Have you seen?
After
okay.
that equals.
Which one?
Like now, because we have a bigger bracket.
Yeah, like this bigger bracket, I've put it to show you that this quarter is going to be affecting everything we have here.
Okay, so I wanted us to put another bracket there, like that.
Okay, perfect. Okay.
Thank you.
Abdallah, come in.
Teacher, I'm just trying.
Okay, integrate for us 1 dx. What do we get?
We get x.
X, good. Minus 2.
Sine 2x.
Integrate well. First, tell me what you get when you integrate cos 2x.
Cos 2x. I think we get a half sine 2x.
A half sine of 2x. Very good.
Yeah.
Plus. Now, okay. Now, allow me now, members, to first take you back here because I want you now to know. Now, we have the integral of cos squared 2x dx. Now, I want you to remember what we had. That when let me write it as side work. We say that when we have cos 2x, this is the same as having 2 cos squared x minus 1. Now, when you look at our angle here, our angle is a 2, but this was a single angle. Now you ask yourself, in order for that angle to be, what was this cos? Which angle was here for this angle to be 2x? Members, which angle was there? Yes, there is something we talked about initially. If this angle squared is x, remember I gave you, Raven has remembered. So we say this was 4x. So in case it is 4x, it means we shall have 2 cos squared 2x minus 1. Members, is that thing okay? People have mentioned. Very good. Now, what are we interested in? We are interested in cos squared 2x. So I'm going to make it the subject. So I'll have cos 4x plus 1 is equal to 2 cos squared of 2x. Now, what are we going to do? I want to remove this 2. So I'll have, I say, cos of 4x plus 1. Everything divided by 2 is equal to cos of squared 2x. Members, are we still together? Are we still together? Or we are leaving some people behind? Are we leaving some people behind or we are together? Elvis is saying we are together. Elvis, together. Yes, we are together, Arthur. Very good. Trying. Abao, don't try. Do. You say, where is the problem? Not. We are together. Abao, have your hand up. Abao, where? Moses. Unmute. Oh. Moses is not unmuting. Some are lost. Yeah. Those who are lost, kindly have your hand raised such that I can know where the problem is, such that we can break it. Because now I'm going to give you Joy. You're also saying there is a problem somewhere. Joy, unmute and share with us. Yes, Joy. Oh, okay. Unfortunately, I'm failing to get you. Now, we are going to come back here. Yes?
I'm lost on the...
Onda? Where? Oh, I'm failing. Okay, now we are going to substitute for our cos squared 2x. So I'll have here cos of 4x plus 1, everything out of 2 dx. But since this 2 is dividing everything, I'm going to remove it. I say I have integral. Now here, I always prefer you people writing it like this. Instead of starting with cos 4x then plus 1. Some of you at times you may make a mistake and think 4x plus 1 is one thing. So that's why I prefer like that. So I'll continue and say this is a half. Then I can put our big bracket and say I'm integrating 1 dx plus I'm integrating cos 4x dx. Now I integrate. This is going to be a half inside. When I integrate 1, I'll have x plus. When I integrate 4, I'll have 1 out of 4. We said differentiate the angle, which is 4. So because 4x, when you differentiate it, you get 4. So you say 1 out of 4. When we integrate cos, we get sine. So I'll say sine of 4x, then plus a constant. So I bring the half inside. So I have a half x plus. Here you have now a half times 1 out of 4, which will give you 1 out of 8. So this will be 1 out of 8. Then sine of 4x plus c. Members, is that fine? Are we together? Pascal is saying yes. Yes, we continue. Or yet Richard is saying yes, I get. Yeah, okay. Now, okay, people are there now. People are there. Now we are going to go back. We are going to go back to our part here where we had the integral, you remember here, and I'm going to put the whole of that thing that we have obtained. So what we have got was a half x plus 1 out of 8 sine, I think it was sine 4x. I want to just confirm a half x, 1 out of 8 sine 4x. Then everything here, I'm going to say plus a constant. Now, since I have a quarter inside, I'll bring the quarter. So here I'll have a quarter x minus this 2 and the 2 cancel. So you'll get 1, but times the quarter, you'll have a quarter sine of 2x plus this a quarter times 1 out of 2 becomes 1 out of 8x plus a quarter times 1 out of 8. That one is what? 8 times 4. That is what? 32. So I'll have 1 out of 32, then sine of 4x, then plus c. But you notice that they are like terms, a quarter x and 1 out of 8x. So those are like terms, a quarter x plus 1 out of 8x. So when you add this is, let me say by 2 by 2. So this is 2 out of 8x plus 1 out of 8x, which gives us 3x out of 8. So a quarter x plus 1 out of 8x is 3 out of 8x. You can put it on your calc, a quarter plus 1 out of 8. So this is 3 out of 8x. So we are going to have this one and this one combined. So I'll say 3 out of 8x minus 1 out of 4 sine 2x plus 1 out of 32 sine of 4x plus a constant. So whenever you integrate sine of 4x dx, that is the answer you get. Members, are we still on the same page? Or we have left some people somewhere? Abawa said yes, we okay. Very good, very good. We are fine. Same page. Okay, let's write now. Do I need to first take you where we started from or papers? Or we are okay to Charlotte, unmute and tell us, do we need to go back to the first page or I leave here and people write this? Or people want to copy what we had at first? Okay, people, you write this, no worries. We'll continue, sir. Okay, now, when you finished writing this, you let me know, and then we continue. Let me give you some 3 minutes. I'm giving you 3 minutes. Okay, okay, okay. I think we are good to go. Okay, someone said, what about when I have sine cube dx? Do not worry, we are going to do it Kiberu, Peter. Yeah. Okay, I have another one. This is now the one we are going to. We shall do sine cubed, we shall do all those, as long as you understand the concepts. That's what I want you to understand. I don't want you to cram, I want you to understand. The moment you understand these things that you don't cram, you will see that mathematics, in fact, even when you spend 5-10 years without doing, you'll find that even you still remember the concepts. So don't cram, understand from the first principles. Understand from the first principles and make sure that you do as many numbers as you can. Whenever you get some time, please go on and do. I wanted to leave this number. I don't know what you think in the chat. It seems we have done a number. We have done this number, but can you allow me to leave it as part of your exercise? Yes. Okay, we do. Okay, we are going to leave it, but just write it somewhere. Because I've noticed we have done a number in the same caliber as we are dealing with sine for x. So you write it somewhere. You write it somewhere. You are going to try it on your own. Yeah, you are going to try it on your own. But the only property I want you to remember is this property, that cos 4x is the same as 2 cos squared 2x minus 1. The moment you know this one, then this number is going to be easy for you. So that is what I want you to apply. So allow me to leave it. Allow me to leave it. Now, Chiberu, I'm going to do cos cubed x. Then for you, you'll do sine cubed x. Okay, now we have cos cubed x. Now, the first two we looked at, we're looking at even powers. But now, what about when we have odd powers? Now, when we have odd powers, we use another approach. And which approach are we going to use? I want you to do you know that, members, I can write this as cos squared x, cos x dx. In other words, I'm expressing it in terms of an even power and at least one other one. Members, is this step fine? How I am getting the cos cubed? Pascal is saying yes. Now, what are we going to do? Now, once we reach this step, we are going to ask ourselves, do we know this identity that sine squared x plus cos squared x is equal to 1? So here it is what do? We eliminate the even power. So I'm going to eliminate cos. So how do I eliminate cos? I'm going to come and I tell myself clearly that cos squared x is the same as 1 minus sine squared x. So where there is cos squared x, I'll put 1 minus sine squared x. So I'm going to come here and I say, this is 1 minus sine squared x cos of x dx. Members, let me know whether we are still together. I'm still waiting. We are. Very good. Now, what do we do? Now, are you seeing this cos we have left? We are going to eliminate it. But this one that I have let inside is what I'm going to say. I'm going to use change of variables. So I'm going to say that let my u equals to sine x. This one inside that I've created sine, then I'm going to get, I want to eliminate the x, so I'll say du is equal to, I differentiate. When I differentiate sine, I'll get cos x dx. But my interest is in the dx, so I'll say du out of cos x is equal to dx. Now, I'll come back here in my equation. Where there is this dx, I'll substitute this. So I'll come here and I say, this is the same as the integral of 1 minus. But we have said sine x is u. So since this is sine squared x, we shall say u squared and I say cos x, I leave it there. I don't have a problem with it. Then dx is du out of cos x. I will say du out of cos of x. Now, mathematically, we know that this and this can cancel. And once they cancel, it means that I remain with an integral of 1 minus u squared du. Members in the chat, can you integrate for me this quickly and put your answer in the chat? Everyone at least put that one in the chat and we see the basic integration now. 1 minus u squared du. When you integrate, write it in terms of u. That's what I'm saying. What do you get? Someone can even raise up the hand. Charlotte, ndagire Charlotte. Charlotte, unmute. Okay, Lona.
U minus u cubed out of 3.
We get u minus u cubed out of 3. Plus
C.
But what was our u, Lona? What was your u? Are you seeing our u, Lona, here? Oh, Lona is muted. Okay, yes, Lona.
Our is sin x.
So we shall say here sin x
minus sin cubed out of 3.
Out of 3.
Plus C.
Plus C. Very good. So that is what we do, members. That's what we do. Now, my assignment is here. My assignment is here. And we are doing it now. We are using 5 minutes. Can everyone now integrate for me sin cubed x dx? Can you integrate it quickly? Use the same approach. You are going to excuse me, but I'm giving you 3 minutes. Hope members are calculating seriously. When you finish, feel free to put your answer in the chat. Blessing Mwanguzi is saying the answer is getting is the third cos cubed x minus cos x. Okay. The rest will agree or disagree. Mayanja Abdu is agreeing. Sandra is agreeing. Abao is agreeing. Chiveru, we are waiting on you. But Charlotte, are you there? Ndagire? Alice Favor, are you picking something?
I'm trying. I'm really trying.
Okay. Okay, but don't worry. I think when in the third week we may have some sessions for your class very soon. Okay, now looking through the chat, I'm seeing people have got the answer. This is very interesting. Allow me to say now, let's continue and try out and do other numbers. Okay, now we have a mixture where they have mixed. You are seeing a sine and a cos, and you are seeing them that they're in the terms of even powers, odd powers. You ask yourself, what do you do? Now, once you meet such numbers, always the first thing that should come into your mind is that which one is easy for me to eliminate? So change of variables here is going to be very key for you. And I'm going to ask you, I want now to test you. We are going to use the change of variable. I'm going to say, when you look at sine squared x and cos of x, you notice that one of them comes from the other. So the easiest one that we can eliminate is the one with the lower power. So the one with the lower power is always easy for us to eliminate. So what am I going to do? I'm going to say that let my u, I'm going to show you two approaches. Then for you, choose which one is easy. So you can say let your u equals to sine of x. What does it mean? It means that our du will equal to, when you differentiate sine, you get cos x dx. Now, when I come back here in my integral, so since I have to eliminate the x, I'll divide this side by cos x, I divide by cos x. So meaning I'll have the u out of cos of x is equal to the x. Now, when I come back here in my integral, where there is the x, we are going to substitute this. Where there is sine squared x, we have already let that it is u. So I'm going to come back here and I say this is 12 u squared cos of x times my dx, which is the u out of cos of x. Now, when you look here, you notice this and this can cancel. So members, this will give us the integral of 12 u squared then the u. Now, the moment you reach here, what do you need to notice? You need to remember, how do we integrate? So when we are integrating, we know very well, okay, this is to help people who are here who have not. When I have an integral of this, we increase the power by 1, and then we divide by the new power, we add our constant. So here, members, we shall have our 12 u power 3 out of 3 plus the constant. Then you can reduce using the mathematics that by 3, 1, by 3, 4. And therefore, I will end up with my 4u 3 plus a constant. But what is my u is sine. So I'll have 4 sine cubed of x plus a constant. Members, is that fine? Is that okay? Is there anyone who needs some support? Sister Daniel said, yeah. Clement is saying, yeah. Okay. That is good. Okay. 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 Okay, it seems members are there. Okay. May I do? And I have another one. Oh, I ask you for you to first try call for me this one. Also, members, can't we first try call this one on our own? And we see? Yeah, true. So let us first try this one on our own and see. So make sure you change, you rate very well. So it is our turn now to, let's do it. I know it is possible. It is possible.
Recording in progress.
Looking through the chat, its members are getting answers. Members are getting answers. Good. Good. Okay. Then I'm saying they are a bit differing, but nothing to do. We are going to try it together and see. Okay. Okay, I think, yes. Now, I've noticed that the answer is a bit differing a bit. So here I expect someone to have told us that I'm going to let my cos of 2x to be equaling to my u. And then I differentiate. So you know that when I differentiate cos, I get negative. So I'll have, this will be negative 2 sine of 2x dx is equal to my du. So my dx will be du out of the negative sine of 2x. Members, is that fine? Is that step fine? Just let me know in the chat that it is okay. Is that one okay? Okay, it is well. Now, what happens when I come here? I will say this is the integral of u power 5 sine of 2x. Then, okay, Arthur, yes, Arthur.
You say the negative, is it negative 2 sine 2x dx, or is that 2 is not supposed to be there?
Which 2? This one?
Yeah.
Oh, no, that one, Arthur, is there. Reason being, when you are integrating, when you are differentiating cos 2x, let me show you. When you say y is equal to cos 2x and you want to differentiate it, we use the chain rule. So we say that dy dx will equal to dy du, then times du dx. Now your u is the angle, this angle here, which is 2x. So when I differentiate, I'll get du dx equaling to 2. Then my y will equal to cos of u, meaning that my dy du will equal to negative sine of u. So when I come here and I substitute dy du is going to be negative sine of u, then du dx is 2, which I can write it as negative 2 sine of u. But what is my u is 2x. So I'll have negative 2 sine of 2x. I don't know whether Arthur, we are together. Arthur, is that fine? Okay, let me hope so. Okay, yes, Mayanja?
Master, for me, I think is just worried about where you have made dx the subject of the formula, because we're leaving out that negative 2 in the final answer.
Okay, this one. Okay, thank you. I had not seen this one, eh? Okay. Thank you. Okay. So here, thank you, Abdal. So here, we shall have our du out of the negative 2 sine of 2x. So when I reach here, I'm going to have this and this one cancel. So I remain with my integral of u5 out of negative 2 du, which I can see write as 1 out of 2 negative integral of u power 5 du. So when I integrate this, I'll have 1 negative a half, then u power 6 out of 6 plus c. So which will be negative u power 6. 2 times 6 is 12 plus c. But what is our u? Our u, we had it as cos 2x. So here I'll expect us to have negative cos power 6 2x out of 12 plus c. So that is the answer. Yeah. So people who didn't have a negative, please check out. There was a problem somewhere. Yeah. Most so when it came to differentiation. Remember, when you are differentiating cos, you get a negative sign. Yeah. So many of you are just forgetting that negative. I don't know whether we are okay now. Are we together, members, on that number? You can let me know through the chat whether it is okay. If you have noticed the mistake. Okay. People are very okay. Let me ask Patrick, yes.
Okay, I would like to ask, you said lower power. When you look at the integral of 12x, 12 sine, from the question, 12 sine squared x cos x dx, me, I thought the one with the least power is the cos x. That's why I'm somehow a little bit confused. Here we are using
Cos
again. Yes.
Yeah,
okay,
now,
from the previous example. Now from this one we are having cos power 5 2x sine 2x. So I thought we are going to pick the power u is going to be sine 2x. You thought of least the one with the lower power we deal with first. That's why I'm somehow confused.
Okay, you come back here on this. Which one did we let here?
From here we said we let u is equal to sine x.
Are you noticing that we consider that one with a higher power?
Yeah.
That function. Isn't it what we are doing here?
The one.
Yes. So what I said about it is that your aim should be the one eliminating the one with the lower power. So by eliminating doesn't mean it is the one that you are going to let, but it is the one that is easier to go away.
Okay. I get you.
Okay. Okay. I think that is fine. Hope we still have some energy and we look at this. Now, when we have to integrate tan squared x, we shall use that identity. But do not forget how that identity comes about. We know that when I have sine squared cos squared x is equal to 1, what happens is that when I divide everything by cos squared x, I divide this side by cos squared x, I divide by cos squared x. Sine out of cos gives us a tan squared x plus cos out of cos gives us a 1. 1 out of cos is the same as our sec squared x. Now, this one is the rule that we shall be applying. So when you find a question whereby in that question you are noticing that there is tan, then we shall be substituting it with sec squared x. Can you take a note somewhere as I answer Sophie? Sophia, unmute Sophia.
Yes, sir. For me, I have a question about the previous number. Because
Yes.
I just joined. If at all I use recognizing the presence of a derivative, do I get the same answer as you guys? Because when I used it, I got something similar to yours. Is it okay?
When you do what?
When I integrate by what? Recognizing the presence of a derivative.
Which did okay, how did you approach it?
I first let f of x be to cos 5 to x.
Cos 5 to x like that?
Yeah, then I said f is it a f what? F inverse of x?
F prime.
F prime of x.
Negative
2 sine.
Negative 2.
Negative 2 sine 2x. Then after.
This is the answer you get when you differentiate this? It's not what you get. In fact, you are supposed to get something like this. So here, when you differentiate, it did not come out. I don't know that you are getting it. Allow me to just show you briefly what you wanted to do. So that's why I think your answer is not the same. Now, when you have, let me say you have, when you want to, instead of using f, allow me to use that. Now, still, when it comes to such numbers and you want to do what? To differentiate, you need to remember the chain rule. It's the one that will help you always. And once you know it, it will make your work a bit much easier. So that is the one that you had to use. But your differentiation, it was not okay. It was not okay. Remember, when it comes to such numbers, here you can say, what can I use? Okay, but you have to drop the power, differentiate this. So you were supposed to get something like 2 sine, but this is negative sine. Then you write back the original thing, reduce the power. So your differentiation here is what is really killing you. So you first differentiate this one well. After differentiating it, that's when you'll get the same answer. Yes, I don't know whether Sophie. Yes, hello, Sophie.
Let me try to use it and see whether I get the same answer.
Yeah, but you have first get that the differentiation very well. Otherwise, the way you were differentiating, it's really not making sense.
Okay, sir.
That is what. In fact, here now you may even find yourself applying about 2 rules. The first rule you need to remember is that when I have, let me say, y is equal to, let me first write just this 5x. When I'm like to differentiate this, I can first say let u equals to cos of x. Are you seeing? Then you know that your du dx is going to be equal to negative sine of x, not so? Then you are going to say that now your y will equal to u power 5. Are you seeing that?
Yes.
Then your dy du is going to be 5u power 4. Now, when you come here in chain rule, to get dy dx, you will say dy du times du dx. After getting that, your dy du was 5u power 4, then times du dx which was negative sign of x. But your u here, this u here was cos x. So meaning that you'll have to get 5 cos 4x. Eh? 4, this,
Yes.
no, sorry, this is time was not x. 4 power 4x, then sine x, but there is a negative.
Negative.
So negative 5 cos 4x sine of x. This is just for cos power 5x. Now, if there is an angle here, which is 2x, then also you need to learn how you have to let that I'm going to, here you can say, let my u equals to cos of 2x. Then you say that your du dx is going to be, when you differentiate cos 2x, you get negative 2 sine of 2x. Hope that is okay. Now, meaning your y is going to be u power 5. Then you say now my dy du is going to be 5 of, this is going to be u power 4. Then you go back to your chain rule that dy dx is going to be dy du, then times du dx. So your dy du, we had 5, then u is cos 2x. I have cos of now power 4 2x, then times du dx, which was negative 2 sine of 2x. So which will end up giving you negative 10 cos 4 2x sine of 2x. Are you seeing? Hope she's still on. Yes. Sophie, that is how you had to approach. So that is what you get. I don't know whether it is fine.
Yeah, it's fine. It's fine, sir.
So, okay. So you try it and then see that you come up to the same answer. But when you look at it, you'll notice that sine the other one is going to cancel. Then up, you remain with cos 2x. And then when you continue like that. Okay.
Okay, so let me try it out. Thank you very much.
Okay. Okay. Members, sorry. Let us now continue. Hope members are finished right here. Now, like we have said, this identity is going to be very important for us whenever we meet that we have tan squared. Because you remember, tan squared is also an even power. Now, if we have such, still we shall say that 1 plus tan squared x is equal to sec, or is equivalent to sec squared. In fact, in good books, you'll find them using equivalent, not equals. But look, it doesn't matter a lot. Now, since we want tan, so we shall just say that tan squared x is equivalent to having our sec squared x minus 1. So I'm going to come here and I say this is the integral. Allow me to put the 2 out. Then I'll have sec squared x minus 1, everything dx. So when I open the brackets, I'll have, when I open the integral, I have sec squared of x dx minus integral of 1 dx. Now, integral of sec squared x, that one you don't need to, you need to just know it from our table here. When you go back, I'm taking you just to the table to see it from our table here. That when I integrate sec squared x, I'll get tan x. So whenever you find integral of sec squared x, you get tan x. So that's what I wanted to show you, that integral of sec squared x is going to be tan x. So here we shall have tan x, then minus, when I integrate this, I'll end up with x, then I'll say plus c. So when I open up here, I'll get 2 tan x minus 2x, then plus a constant. Then that would be my answer. Members, are we still together? Is that fine? Is that okay? Very fine. Okay, let's write. And then I give you some numbers that you are going to do to refresh in the evening. I'm going to give you some numbers to refresh in the evening. So let us first do. Okay. People are saying we can continue. Now what we are going to do, I want you to take screenshots. These are the numbers I want you to try out in the evening. And let me hope members know how to do the substitution. Yes, Abdallah. Abdallah?
Teacher, I'm just asking you a question.
Hmm.
Like, where can I get those referral questions in Backhouse 1 or Backhouse 2?
Where can you get?
Those trial questions in the Backhouses, either 1 or 2.
Yes, those questions are there. Let me check whether I can access Backhouse here. Then I will show you.
Okay, then another thing.
Hmm.
We didn't have physics lesson last week.
Okay, I'm going to talk about it.
Okay.
Okay. Yes, Sandra. Hope members have finished. Seems people.